All right, we're moving on to the acceleration questions, and as always, let's be careful and label our letters. So we have a car slowing down to stop at a speed of 40 meters per second over 200 meters. We want to know its acceleration and the time to stop. So we start off at 40 meters per second. Our time is unknown. Our acceleration is unknown. We actually do come to stop, so that means our final speed is 0. We always start off our initial position as 0 if we're not sure, and then we actually travel over 200 meters. So for the acceleration, let's use the formula that doesn't have time to see if we can do something with it. So we have 0 squared is 40 squared plus 2 times a times 200 minus 0, and we end up getting negative 1600, a couple of steps there, equals 400 times a. We divide both sides by 400, and what we end up getting is that a is negative 4 meters per second squared. Now let's get the time to stop, and for that, part B, I'll move this over a little bit, yeah, there we go. For part B, we'll do v is at plus v naught. 0 is negative 4 times t plus 40. We subtract 40 from both sides. We're going to get negative 40 is negative 4 times t. We'll divide by negative 4. And then we're going to end up getting 10 seconds is the time. It's problem 3. 4, a ball is dropped from a cliff of a height 120 meters. How long does it take to hit the ground? What was its final velocity? If things drop, so we know that x naught is 120, because that's how high up it starts. It hits the ground, which is 0. The acceleration is negative 10 meters per second squared, since it's falling. The time is unknown. It starts off from rest, and it ends up at an unknown velocity. So how long does it take to hit the ground? Let's see. X is 1/2 at squared plus v naught t plus x naught. 0 is 1/2 times negative 5 times t squared plus 0 times t plus x naught, which is 120. I'm going to end up getting 0 equals negative 5/2 t squared plus 120. I'll add 5/2 t squared to both sides and get 5/2 t squared is 120. I'm going to multiply both sides by 2, so I'll get 5t squared is 240. We'll divide both sides by 5. T squared is 4 times 5, 48. And t ends up being 6.9 seconds. For part B, we want the speed, or the final velocity. V is at plus v naught. V is negative 10 times 6.9 plus 0. So V ends up being minus 69 meters per second. And that's part B. For part C, a ball is thrown downward with a speed of 20 meters per second, and we want to know how far it's fallen after 3 seconds. So for part A, let's be careful. V naught is 20, and that's downward, so it's negative 20 meters per second. A is negative 10 meters per second squared. We don't know V final. We don't know how far it's going to fall. We do know the time is 3, and we know that the final position is unknown. So let's solve part A. So we get that x is 1/2 at squared plus v naught t plus x naught. And that's x is 1/2 times -10 times 3 squared plus -20 times 3 plus 0. X ends up being -45 minus 60, or -105 meters. So it falls 105 meters. That's if you have an initial launching speed. Now for part B, it's going to be very similar data. In fact, I'm just going to steal a lot of this stuff here. Whoops. And we're going to change one thing, two things actually. This is part B. Awesome. And this is now 0 meters per second. So we can actually do a similar calculation to what we have here. And we're going to get that x is 1/2 -10 times 3 squared plus 0 plus 0. X ends up being a mere 45 meters, so when you add that extra launching speed, throwing it downwards, you actually fall further down the cliff, which makes some sense. So that's questions 3, 4, and 5.